Mm-hmm.
Oh, so
I'm
really we're
checking
all
out.
Grand Theft Auto, so if
I'm
we
not
just
coming
bring Grand
next
Theft
semester,
Auto and
guys.
play it,
Are
it's
you
just
serious?
playing
No,
live.
I'm kidding.
Okay.
I was like, really? Oh my god.
All right, let's do a problem.
I'll Call of Duty.
Let's see, we did one yesterday that had, let's see, I want to do something a little different than what we did yesterday. Let's do something like, how about,
Like,
did that one, I want to find one like that. There we go. That's a good one. All right.
Waste.
Okay. I want you to find everything. So I want you to find intervals where the function is increasing and decreasing, as well as all of the relative extrema, and they kind of go together, right? So what do we got to do?
so change it.
Okay, so we're going to differentiate. Yeah. All right. So f prime of x is what?
2/3 time. To the negative 1/3 times 2x.
Okay. So why don't we write that as a fraction? That's a good idea, right? So we're going to write this then as what goes on the top
2
times,
the 2x.
so
So
4x. What goes on the bottom?
3x.
times
Three
the
to
1
parentheses.
x.
Yeah, x equals 4.
Negative.
Right?
Wait, wouldn't there be a
Whoa.
Oil
Yeah.
waxing.
That scare you?
Probably not sound oil.
Okay, everybody good with that? Negative puts it on the bottom.
I just realized that. I was like, oh, wait, never mind.
Okay, so then let's find our critical numbers, right? Now this is there's some good stuff here. Okay, so critical numbers occur where the derivative is 0 or undefined, right? Okay, when is that function equal to 0?
X is 0.
When the bottom.
Okay, good. Yeah, when the top is 0, right? So f prime equals 0 when 4x equals 0,
On the
which
bottom,
is,
what you get is 0.
what's that?
On the bottom, what you get like a negative.
Doesn't matter because 0
You'd be undefined then.
Okay, so what about the bottom? So what do we got going here? On the bottom, where is this going to be undefined? Now we got two things we got to kind of look at here, right? We would say that the derivative is undefined when either the bottom equals 0 or bottom or top, we take an even root of a negative number, right? Okay, so,
What about an odd root?
okay, but an odd root is fine. What is the cube root of negative 8?
2. Negative 2.
Negative 2, right? Okay, that's fine. We can do that. So we don't have to worry about the root part, but we do have to worry about where the bottom is equal to 0, right? But let's make this easy, right? Let's make this a situation where we don't have to do something complicated. When is the function on the bottom going to equal 0?
2.
How'd you get that?
Because
But that's not the only answer. But what's the part that we...
2 squared equals 4, and 4 minus 4 is 0.
Okay, but what's the part that we're setting equal to 0?
Square root.
The cube root? Okay, but we don't even have to do the cube root. We can just do the argument of the cube root.
So the
Right.
inside-
You see what I'm saying? This is really important. This makes life a lot easier. So we could make the statement here. F prime is undefined when that equals 0, right? That's the part we're concerned about. Does that make sense? So we don't have to set the entire bottom equal to 0. We can avoid some algebra steps here. We can just pick the part of the bottom that's going to cause the bottom to go to 0 and just deal with that instead, right? So when x squared minus 4 equals 0, which is when x squared equals 4, which is when x equals
Two or negative.
plus or minus 2. Good. Okay, make sense? All right, so now let's make our table. So there's the x-axis. I guess we'll call, how about I call it f? The word f. Okay, what's our domain? All reals. No restrictions, right? Because is that an odd or an even root up there in the function? It's odd, isn't it? Because it's the denominator that matters, right? That determines the index of the, that's equivalent to the index of the radical. So our domain looks like that. And what are our critical numbers then?
0, -2, +2.
Okay, so we got 0, -2, +2. What's going on there? It's 0. What's the derivative? 0. And at -2 and +2, what's the derivative?
Undefined.
Undefined. Okay.
Is there like a symbol for undefined or is it?
No, I just either write U N D, but U works too, right? I mean, that's the only thing that's going to stand for. Okay. So, what do we do?
Wait, do you need to, is that one thing you
What's that?
was,
Where it's, say it again?
like,
No, it's a
do
good
you
question.
Do you need to find the middle row? Like, was that one of your things?
Uh,
'Cause
no.
You listed a bunch of things.
Nope, never. I never really wanted to know the middle row. We don't need to. If we needed to know the coordinates of the points, like if we were sketching a graph or something, then yeah, we might want those, right? But I never asked that. I just want to know where are, meaning when we ask a question like where are, we're talking about the independent variable, right? The values of x where it's happening. I want to know where are the relative extrema, and on what intervals is the function increasing and decreasing. Okay? So the middle row is irrelevant to this conversation. Okay? Because we want to work as low as we can. So now what?
First derivative test.
What's that?
Don't you need to do the first derivative test to like?
We do.
pick points?
So, but to do the first derivative test, what do I need?
Points.
Points. Need some test points. So what are convenient ones?
1 and -1. Oh, 6.
And then, what else? Whatever,
3 and
right? 3 and -3. Okay? So let's look at the sign of the second derivative. That's all we need. So let's play a sign game here. How many factors are there in this problem that matter? With 4/3 is just positive, right? What are the other factors?
X on top.
X on top and the cube root on the bottom, right? Okay, so all we have to do is evaluate the signs of those and see what we get. So then here's how I like to do this. I would say something like f prime of -3 equals what? So what's the sign of the top going to be?
Negative.
Negative. What's the sign of the bottom going to be if I evaluated it at -3? Positive. Negative over positive is what? Hey.
Not even alive.
So the overall sign then is negative. How about f prime of -1? Top is negative, bottom is
Negative.
negative, overall sign is
Positive.
positive. Okay. What about f prime of 1?
Positive over negative.
Positive over negative, so it's negative, and f prime of 3?
Positive over positive.
positive over positive, so it's positive. Okay? So we can do one more cool thing here. We could say, okay, now, if this is going from negative to positive, what does that make this extremum?
The minimum.
Point.
A minimum, right? Because it's decreasing to increasing, right? Okay? Furthermore, it's a first derivative that's undefined. So what's the nature of that valley?
Sharp corner.
It's going to be a sharp corner valley. So look what we can do. We can do something like that, right? That's our little icon that represents what's going on there, right? What about here? We're going from positive to negative with a 0 first derivative.
So smooth corners. Peak and maximum.
So that's going to be something like, yeah, there's our icon, right? How about here? That's the same as that, isn't it?
Yeah.
So we go, and we know everything, don't we? Right?
World.
So if we want to write down, let's say we want to find out where the relative extrema are, well, we have relative minima at x equals what?
2, negative 2.
Negative 2 and positive 2. And we have a relative maximum at
0.
0. If we want to know the intervals where the function is increasing and decreasing, we could say that f is increasing on what intervals?
Negative 2 to 0.
No, it's like,
Negative 2, 2.
Negative
two
to
negative
0.
infinity,
and
isn't it?
two.
What do you think?
Well, no,
Where is it
wait,
increasing?
Negative 2 to 0.
Wait.
Okay, where it's positive first derivative, right?
Yeah.
So it's going to be on this interval. So negative
We're
2
just messing with you.
to 0, or
2
2 to infinity. Definity. 2 to.
okay, it's decreasing on
Negative infinity. Negative 2. 0.
boom. Got it. Okay. Make sense? Okay. Questions?
So, on our calculator, like if we plug the function into our calculator, does the way that it finds the graph, is that by just plugging every single point effectively into it, or does it like actually do this right here, or some variation?
It's gonna do
of
something
that?
like this.
How do calculators work?
It's
Pop open that can of beans.
yeah, they're gonna do some algorithms that do approximations. Yeah, I mean a graph. If it's a computer algebra system, it's gonna be more accurate. Then it's gonna actually solve symbolically. But those aren't. TI-84s aren't. TI-89s are.
So like when you do like something where it's like, 112 divided by 13,000, is that just like already programmed in the calculator, like the answer?
Yeah, there's some functions that do that stuff.
Okay.
Yeah, that they rely on. Yeah. Okay.
Sims.